Hello everyone, for first updates now, I'm Tyler Olds and you're watching Behind the Bot. It's fun show we dive deeper into FTC robots and what makes them work. And today I'm here with team number 12589, Pioneer Robotics, coming out of Shrewsbury, Massachusetts. 12589 won the Inspire Award at States along with placing 5th, and then also their qualifiers placed 3rd. And to help me speak about this robot today, I have Manib and Brendan. And we're going to be going through this robot. Lots of cool stuff to cover on this dual intake system. An interesting wobble goal manipulator. I know it went through a couple different processes to get where you are. Of course, odometry pods, ring sticks, all this and more are coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or a career that supports you being in FIRST, check out careers.stryker.com to learn more. Hey FTC fans, are you ready for Freight Frenzy? Join us after kickoff live all weekend, September 18th and 19th, as we'll be out at Kettering University for the Bulldogs Robot in 30 Hours at youtube.com/first updates now. You'll get detailed breakdowns of game elements, the field, and prototyping and testing of robot components and assemblies. Watch live, view short videos after, and ask questions for the Kettering team at youtube.com/first updates now. So Manib, take us through on this robot here. We're going to be starting out with your intake system. You have a dual intake. I'm really excited to talk about kind of how that works together in conjunction, and we'll kind of run us through the rest of the ring journey. So start out with that.
Yeah, so our plan this year was to create a system that'll be able to collect a ring efficiently from both the front and the back of the robot. So if we do a quick demo of the front of the robot, you can see that we have 4 axles that'll transition the ring from the bottom up to the top. We have this bar here that'll prevent stacked rings from clogging up the intake. But the really interesting part of our robot, I would say, is our rear intake. So let's run that through. You can see that the ring pops out from the other side. It's a bit hard to see, but there we go. And if we look at it from the underside of the robot, we have these 2 belts that work in parallel together to pull a ring from this area here up to this point of the intake. The ring essentially wraps around this axle and is carried up to our intake magazine. All right.
I'm very curious, by the way, how does that wraparound part actually work? So you're actually moving the ring, quite a bit then, right? You're actually angling it quite a bit. Can you actually like walk the ring through that area just so we can see what that looks like?
Sure. So earlier this year, we took a video of the robot on top of a piece of plexiglass. And if we look at it over here, you can see that when a ring comes into the robot, if you just give it a second there, when it comes in, it essentially bends around that axle, pretty much a 45-degree angle.
So how does that not like pop your robot up or anything like that? Like, did you do any calculations to figure out like, hey, the amount of force this ends up putting into this type of material isn't going to make our robot pop up in the air or anything like that?
Yeah, it's a really good question. And so at the beginning of this year, we did a lot of testing on a quick jig that we made, and we would elevate the height until we could figure out a good spot where the robot isn't popping off the ground and the ring isn't, changing the direction of the robot while it's moving. But if there's ever a situation where there is a jam, our odometry pods, which are on spring-loaded bases, keep the robot's direction intact.
Next up, we're going to go through the conveyor system. So we got the ring in tow, and now it's going to go into the conveyor. Talk to us a little bit about what that consists of.
Yeah, sure. So we got this metal ramp at the back, and that essentially just directs the ring upwards. We have these 5 axles, and each of them use custom printed pulleys made out of nylon, and these belts essentially keep the ring from popping out through the conveyor system. And eventually, it reaches up to the top. One thing that we thought of is to add these tines. Sometimes a ring will come and it'll be kind of propped up like that, but if we run the intake, these tines hit the ring until it's flying to the robot. Essentially, when other rings and when we got 3 rings in there, it works nearly all the time.
Well, it looks really good so far. Brennan, we're going to be going into the shooter mechanism next. So talk to us about what that all entails for it. Really curious to hear about your flywheel choice and how you did maybe some of the calculations on like how much compression you wanted to put on the rings, that sort of thing. So walk us through some of the concept and design of your shooter mechanism.
Okay, so our base of our shooter mechanism is this large 3D printed plastic part, which the rings fall from the conveyor belt into. Connected to this, we have this motor with a flywheel. This motor is a 6,000 RPM motor, and it's geared one-to-one to this flywheel with a belt. Our flywheel is actually weighted. We have this large metal disc which we CNC'd underneath it, which allows it to conserve momentum as it's firing the rings, even after the force of the rings acts on it. Also, to calculate the distance and range of our flywheel in perfect angle, we actually used a lot of math and kinematics using graphing in order to determine the best possible velocity and height for this launching mechanism. And to calculate the compression that we needed, we actually just did a ton of testing with it. And same thing with figuring out the best type of flywheel to use. We actually tested out tons of different flywheels from different companies and made of various materials.
So two follow-up questions. First of all, what is the material that's actually on that wheel there? And then second thing is, you mentioned, having the more weight, you're right, doesn't, you don't need to wait as long to refire or get ready to fire again, but it does take longer to usually spin back up. So are you keeping that motor going the entire match, or how long does it take for you to respin up every time?
So the material on this flywheel, this is an Andy Mark Stealth. This is just an Andy Mark Stealth wheel. So it's just an outer rubber material.
Just a well-used Andy Mark Stealth wheel, I see.
Yeah.
All right,
and
got it.
Under here, we have this custom CNC'd weight. And this weight, so it takes longer to spin up at the beginning of the match. If we keep it running throughout the entire match, so we don't have to waste time like spinning it up again. So it'll just be running, and that has a lot of benefits to it, such as we can fire the rings consecutively. And we noticed that we don't really have to slow it down. It doesn't affect the performance of the robot if we keep it running the entire match.
So let's start to go through more areas that are more closely to your chassis on there. So you have some ring sticks to knock those down. You mentioned odometry before, so why don't you start out with those two things and we'll kind of dive a little bit deeper.
So our odometry modules are right here. So we have two parallel ones. We have one perpendicular one to the wheels on the chassis to measure rotation, X and Y movement on the field. So these are 3D printed out of nylon, and we just use S4T encoders because those have a dust-proof housing, which makes it so no dust gets in there, even if our field gets dirty, as opposed to E4T encoders, which several teams have been using, which have optical encoders, which get very dirty over time. The sticks which knock down our rings, you can see that you can toggle them so that the driver can just drop them down when the rings are coming out of the chute, so that we can knock them down and then intake them with our rear intake.
So a couple last things to talk about on your robot. I noticed that you have a camera on there, but camera actually articulates a little bit. So tell us a little bit more about what's articulating it, why you chose to have that camera move, and then lastly, don't want to forget your wobble goal mechanism if anybody wants to cover a little bit more about that too.
So our camera actually articulates up and down. So at the beginning of the match, it'll be facing down at the stack of rings, so we can determine which case it is, and then afterwards, after we determine which case it is, it'll look upwards at the tower goal, and then it'll be able to find the tower goal and launch the rings into the tower goal.
And then lastly, walk us through your wobble goal mechanism, what you're using for that, and then really some of the iterations you went through. That's really, to me, what I always love to hear about is like, what did you start with and how did you come up with what you had right now?
So this is our wobble goal mechanism. We just have a simple servo, which is geared up right here. Go build a torque servo. And for the grabber, we have this custom plastic piece and another custom part right here, which actually interlock. And you notice that it has this nice curved design, and it allows us so that we have a large degree of error when closing. It'll actually bring the wobble goal towards us into the robot, and then we can pick it up like that, just with the same servo.
Well, that actually might be one of the largest degrees of error I've seen from any team so far. So really cool on that. Well, once again, thank you for taking the time. 12589 Pioneer Robotics coming out of Massachusetts. Congratulations on your success this year as well. And really appreciate you taking the time to show off your robot. Thanks a lot, guys.
Thank you.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.